Hello. In this video, we are going to go over derivatives and specifically the power rule of derivatives. And we are going to apply them into these three equations, and it'll be very simple and easy once we've gone through these three examples. The power rule first is, if we go over it very quickly, with the derivative with respect to x of n to the power of x, where n is just a number, what we need to do is multiply our derivative and bring it to the front, okay? So the the exponent comes to the front. Sorry, I misspoke. When we are taking our derivative, we're going to bring our exponent and multiply it to the front. So our exponent comes in front. The n will not change, but the exponent up here will be subtracted by 1. And that's it. So we're going to take the exponent, multiply it to the coefficient or the front or the 1 or whatever's there, and then subtract that exponent by 1 and leave it there. And that will be that. So now that we've gone over that, let's apply it to some of these problems. Let's start with number 2. Number 2, all I'm going to do first is we apply the derivative to both sides, f prime of x. And then what we need to do is we're going to take that exponent, multiply it to the current coefficient. What is 18 times 5? That is 90. And we are going to subtract 1 from that exponent. 18 minus 1 is 17. So if it's helpful, I can do an extra step to show kind of that little change. So what happened is we found f prime of x. Our 5, our coefficient stayed. We multiplied by our exponent, and our exponent was subtracted by 1. We cleaned it all up. We get 18 times 5 is 90. 18 minus 1 is 17. Let's apply it to number 4 now. Looking at number 4, again, the coefficient just stays. Don't worry about it. We take the exponent and bring it to the front. So 4, we're going to take the exponent, subtract it by 1. 4 minus 1 is 3. Next, we will move to the next number. This has an exponent of 1. So this is still a power rule. We will keep our 5. The 1 gets multiplied to the front. And this becomes a 1 minus 1, which is a 0. We'll deal with that later in a moment. And then next, we'll go over a very fast thing, is if we have the derivative of just a constant, it is always equal to 0. So the derivative of -3 is just 0. And we don't need to write. We don't need to put it. So I'll take that out, and I'll just write that there. That's a little confusing. I'll leave it as plus 0. Now we're going to clean it up. 4 times 4 is 16. X cubed stays. 5 times 1 is 5. X to the 0 was anything to the power of 0. Anything to the power of 0 is always 1. And then we have our final answer once we've fully cleaned it up. 16x to the cube minus 5. That is what my f prime of x is equal to using the power rule. Very easy. Let's do this one last one and let's get out of here. Looking at this guy, we notice that our exponents are in the denominators, and that's an issue for us. What we need to do is bring those exponents to the top. And what we know is that if I can do that, if those were negative exponents, because we know a negative exponent will push whatever's on the numerator to the denominator and whatever's on the denominator to the numerator, respectively. So we have this. -3s to the -2 is equal to, so minus 4s to the -4. And we just do our normal power rule. -2, -3 stays, -2 gets brought in front. -2 minus 1, you have to be careful with, because it's going to be -3. Don't make the mistake of adding 1 there. Next, we're going to keep the -4, bring the exponent to the front. S, subtract -4 from 1, we have a -5. we are going to clean up and bring any negative exponents to the denominator. 6s cubed plus 16s fifth will be our final answer. If you have any questions, please leave in the comments, and I will always be happy to make another video addressing those concerns. Thank you. Hope everyone has a great day.